Today we're going to start our lessons about acids and bases, and so the first thing we need to know is some properties. So these are just some things that you'll need to know about acids and bases. Acids are always going to taste sour. One example is hydrochloric acid. We talked about that's in your stomach, and that's why when you throw up you have that awful taste in your mouth that's kind of sour, and that's because of the acid. And then there's also citric acid in anything like lemon juice, orange juice, grapefruit juice. They all have an acid as well. So just remember, acids taste sour. The main purpose of an acid is to release the hydrogen ion. Notice that it's in bold and underlined, so put a star by that. Acids are always going to give off H+. And when I say H+, sometimes you'll see H3O+ instead. Those are actually the same thing. H+ doesn't really exist by itself in nature, so it's automatically going to stick to water and make H3O+. But the water doesn't really affect much for these acid-base reactions, and so you can just think of it like H+. Acids are also going to be electrolytes because they produce charged particles. So we've talked about electrolytes several times now. These are things that have free-flowing charged particles, and that's why they can conduct electricity. An indicator is something that changes color based on pH. So you probably have seen litmus paper before, and we're going to do a lab with this in class. But litmus paper will turn red when you put it into an acid. And there's another common indicator in chemistry called phenolphthalein. It's a really funny looking word. It's got a lot of consonants, but we'll use this in class as well. It's just going to be clear if it's an acid. And when we say H+, we're referring to just a proton because it actually has no neutrons and no electrons in it. So it's really just a proton. So if I say monoprotic, mono means one and protic means proton. So what that's saying is that you have one H+ to give away. And you'll see that because the acid is written with the hydrogens in front, and those hydrogens are the ones that can be given away. So for the first one, HNO3 has one hydrogen, HCl has one hydrogen. If you look at acetic acid, that last one, you'll notice that it has a total of 4 hydrogens in it, but notice that they're separate so that the first hydrogen is all by itself. What that means is that those other 3 hydrogens are kind of trapped inside the polyatomic ion, and they're not going to be given away. So even though it has a total of 4 hydrogens, it's still monoprotic because it only has one that can be donated. And they'll show that by separating that one out. And then diprotic is 2 hydrogens and triprotic is 3. For bases, they have a very bitter taste. Any kind of soap or cleaner is going to have a base in it. So if you've ever had your mouth washed out with soap, if you've ever said something bad and you have that happen like in Christmas Story, you'll notice that it tastes very bitter. And they always feel slippery, so if you're washing a beaker out and your hands feel really slippery, it's probably because there's a base in there. Some common examples are sodium hydroxide, and then ammonia is a very common one as well, NH3, and any kind of soap as well. Most bases are going to release hydroxide, OH-, but notice that the word most is there. Not all bases will do this. They're still electrolytes because they're going to produce charged particles. And for acid-base indicators, bases are going to go towards the blue side of the rainbow, and the phenolphthalein will turn a really bright hot pink. And again, you'll see those two in the lab that we're going to do soon. There's 2 definitions of acids and bases. We're just going to do one for this lesson. It's called the Arrhenius theory. So the Arrhenius theory says that acids will always produce H+ ions, and bases will produce the OH- ions. Those are 2 definitions that you need to know. Acids produce the H+, bases produce the OH-. Those 2 are going to come together to make water. So for a neutralization reaction, and this is important, so you might want to put a star by it, you're always going to have an acid that has the hydrogen, base that has the hydroxide, and they're going to react so that you get water from the H and the OH, and then what you're left over with is salt. And when I say salt in chemistry, it doesn't mean table salt. In the real world, that's probably what most people are referring to, but in chemistry, the word salt just means any kind of ionic compound. So the salt is what's left over after you take out the H and the OH to make water. So again, a salt is any ionic compound formed from the leftovers of the acid and the base. So here's an example. The HCl is the acid because it starts with the H, MgOH2 is the base because it has OH minus. The H and the OH are going to come together to make water, so notice that we have water over here. And be careful with this, a lot of people try to write weird things here like H2O4 or H5O or something because they're looking at all these numbers over here. Don't worry about the numbers, you'll go back and balance it later. So always just write H2O, that's the only thing that water can be. And then these two are from what's left over after you take out the H and the OH. So if you look on this side and ignore the H and OH, you see we have magnesium and chlorine. Don't forget to put the magnesium first, and don't forget to cross your charges, and then you just have to go back and balance it. So here's another example. We've got, here's the acid because we have hydrogen first. This is the base because we have OH minus. The H and the OH come together to make water, and notice that I just wrote H2O, I didn't write anything else. And then the sodium and the carbonate come together as well, but keep the positive one first, so it's important that you write sodium first, and don't forget to cross your charges. So sodium is +1, carbonate's -2. And then you just have to go back and balance it. And you'll notice that for neutralization reactions, it's really just a double replacement reaction. It's the same thing as double replacement, it's just a specific kind. So here's a few examples. For the first one, notice that we're starting with the acid, so take off the H from that. You're going to take off the OH from sodium hydroxide and put those together. So on the right side of the arrow you'll have H2O. Then you're going to put the sodium and chlorine together, but make sure you write sodium first because it's the positive one. So you should write NaCl. Na is positive and Cl is negative, so those cancel out. And then it's actually already balanced, so that one's not too bad. For the second one, we've got an acid and a base, so we're going to take off H and OH and stick them together to make water. So on the right side of the arrow, put H2O. Then we're going to take the calcium and the acetate. C2H3O2 is a polyatomic ion, so you'll take that whole group of atoms together. But put calcium first because it's the positive one. So you have Ca and then C2H3O2. But you need to cross your charges. So calcium is +2 and acetate is -1. So you need to put parentheses around that CHO and bring the +2 down. So your final answer is Ca parentheses C2H3O2 parentheses 2. Then you just have to go back and balance it. And I always suggest that you balance the salt first. So we have 1 calcium on each side. We have 1 acetate on the left and 2 on the right. So you need to put a 2 in front of the acid and 2 in front of the H, C2H3O2. And then you notice that we have 2 H's and 2 OH's, so you need a 2 in front of the water. And when you're balancing these, if you have trouble balancing water, just rewrite it as HOH, and sometimes that'll help. And then for that last one, you're going to put the H with the OH to make water. Put the aluminum with the bromine, but don't forget to write aluminum first, so you have AlBr. And then cross your charges. Aluminum is +3 and bromine is -1. So when you cross it down, you end up with AlBr3. And then to balance it, do your salt first. Aluminum looks good. Bromine we need to fix. So if we put a 3 in front of HBr, then bromine is good. And then do water last, and notice that we have 3 H's and 3 OH's, so if we put a 3 in front of the water, it will be balanced. And I want you to stop here and take a look at worksheet 4. All of those are neutralization reactions, but they're missing something. They're either missing the acid, the base, the salt, or the water. So fill in what they're missing. Don't forget to cross your charges on everything, even the acid and the base. And then don't forget to go back and balance it. And that's it.